Hello guys, and welcome back to this rather unusual episode. As you can see behind me, the sim is in its location and nothing has changed. I have just been way too busy to pay any attention. It's been nice to have a little break, but I walk past it every day and think I really must get a move on. I received an email from Mick in the UK who said he purchased a Poldragonet pedestal system. He can't get it to work and wants to convert it to Arduino. So he sent me this package. It's travelled 8,000 miles to Brunei. We're going to pin it out. We're going to remove the two 8-bit microcontrollers because they have single pin digit inputs, which means it works on a bus and I don't know what bus they were using. It's going to be quite simply just to remove them and connect them to a Max 7219 board. Use the pin outs here to connect them to the various Arduino pins that we're going to need. And hopefully if Mick's watching, he'll be able to follow along and convert the rest of the panels using the same process. So, without further ado, let's take the panel apart. So the first thing I want to do is strip it down. Now I don't know if Mick's just sent the bare essentials because there are parts missing, the knobs, the button here, and I'm going to guess the back plate is also missing. But quickly take this apart. Now I have already researched the two chips, the two 8-bit microcontrollers and the 7-segment displays. They are common cathode. Which means they should work with the Max 7219 board. Okay, so first of all, we're going to look at CAN bus 1, CM1, and I will draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Flip it over. And I can see straight away that these two pins here are connected, these two pins here are connected, see where the ground goes to. So the plan of action right now is to remove both the PIC bases, the chip bases, all the resistors because they're not required, and put shorten links in there, and that means then we can connect the wires directly to the base where the base pins were. And that is the first row of resistors moved. As you can see, things have slightly changed. I was reviewing the footage of the stuff that I'd taken so far. It's the first time I've done any close-up work and realised that everything wasn't going to plan. Everything was out of focus in the filming. It was just too far away for you to see anything. So I've been out to the workshop, quickly knocked up this Z frame, which now allows the camera to get a lot closer, and hopefully you, especially Mick, will be able to see what I'm doing with his board now. So here we have the Max 7219 board. I've pulled the displays out, but I need to remove the display sockets here. Simply flip it over, and you have to be very careful with these. The pads break really easy. Well, that's what I've certainly found with these ones. It's just simpler to cut each one, pull the pins out, and then clear the holes. I find it just so much quicker and less damage created to the board. That's the sockets removed and all the holes clear, ready to accept the wires to attach to Mick's board. So the plan will be, I've said this a million times already, but is to fit shorted links where the resistors were and then use these pins to connect directly to the pins of the Max 1729 board here. And to do that, I'm going to flip the board over and attach the board like that with some screws coming through from the back to support it. That'll be the first board and the second board on top. So into fitting the shorting links, as you can see, I fitted the first one and now it's just a matter of fitting all 14. That's all 14 shorting links now installed in the resistors. Flip the board over, there's all the legs. Now I've just got to solder them all up. That's the first set done. Trim the legs. With the shorting links installed, it's now in time to install the first Max 7219 board. And I'm just going to drill 2 holes in the PCB and mount some screws in to support the 2 boards. That's 1 hole done. So before I install my Max 7219 board, I need to solder the wires together. And pins 12, 6, 8, 9 and 12 on the opposite side are the common cathodes for the ones we need. So I'm going to use blue for the common cathode, starting with pin 12, which is this top one up here. Spin it round. Oh, that was a bit silly, wasn't it? And then solder that in. This pin here is digit 1, digit 2, digit 3, digit 4. And because we've got 5 digits on the old board, we need to use pin 12 off the right hand side. Okay, so with all the wires installed, so it goes at the bottom starting at 1, 2, 3, 4, 5, 6, over to the top on the same side, 7, 8, 9, 10, 11 and 12. So we want pin 9, 7, 8, 9 is this blue one here, going to that pin there. So before we go any further, I need to take these pins out here, desolder them, and then fit the wires over to the CM1 bus here. Okay, so onto the ground. That's it. Now, I'm leaving these cables long so the PCB, the Max board 7219, can easily be taken off without having to desolder everything to get to the components behind. The reason why I'm doing that is if one of these 7-segment displays fails, he can just change it without having to desolder absolutely everything. And this goes into pin 4 of the chip. And the ground should be right now. Oh, it goes in perfect. Okay, the data pins to the Arduino need to connect to this connector here. To get these 3 wires here, over down to here, I'm going to drill a hole right here in the PCB, feed them through, and then run them along this side of the board to these 3 pins here. So let me get my drill. So before we put the second PCB on, I need to be able to connect it, and I think I'm going to be able to do that by flipping it over and then using sockets to connect them together. But that means that this pin out here is back to front, so we need to take them out, swap it over so it's facing the other way. Oh, need some extra nuts. And next up I need to solder these together. And these will connect the 2 boards together. With the new socket assembly, hopefully just slot on like that. Now to connect all these down to here. But I think what we'll do is take it back off, now that we know that that's going to work, so everything's the right way round, so I don't get everything back to front. Oh, let's pull the sockets out. So first up, let's do the ground and the power. I think that's all the wires connected now. Let's put our socket assembly in and then try and feed this all together. They're in, they're in. See if we can tidy these cables up now. So there you can see the join, the connector which joins the 2 boards together. Let's head over to the computer to test it. Well, it's time for the moment of truth. We'll hook this up to the test Arduino here. As you can see, I've got P3D running in the background, ProSim running, and MobiFlight here. I'm going to put the panel on just to get that full finish. And this will really be the moment of truth to see how well we've done. So there's our radio panel. Time to hook it up. The ground and power first, they're the easiest ones. Put them in to those 2. I like to use orange for DIN. And I will use 2, 3, 4. 2, 3, 4. Okay, that's the 7 segments connected. However, we also want the switches to work and the encoders to work. So I'll use another ground here. I've put the data input into the output rather than the input. So let's just correct that fault. So, orange, yellow and green. Well, that works much better when you put them on the right terminals. That is good. Stop. I'm now selecting the other display, which is there. That's working great. Over to Moby Flight first. Once Moby Flight is open, head over to Extras, Settings, and Moby Flight Modules. I've already got the LED display here. I just need to change the number to 2. The pins are already logged at 2, 3, 4. I'm now adding the button on pin 5, the encoder on 6 and 7, and another encoder on 8 and 9. Make sure you upload, push OK. And that is the board set up, ready to go. So into the output, edit the description. So we're going to have VHF Captain, and this is going to be the 7-segment display, the active one. Click edit. The first thing you need to do is change the offset. I'm going to use the offset 66 echo 0, and the bytes are 4 for a display. Select which module it is. So we only want the first 5 digits in the decimal place on 3. Push test, and as you can see, that works fine. Into the second line, this will be the standard display. Into edit, change the offset again, this time to 66 echo 4, 4 bytes. Into display, select the same display, but this time change the number to the number 2. Select the 5 digits, the decimal place, and push test. This is where I realised I had them back to front. Good. Over to the inputs, starting off with the transfer switch. Edit the description, there we go. Into input, this time select the button. This time we need to select FSU IPC offset and put in 66 Charlie 0. Now these are the offsets that I've got in my ProSim value. They can be any as long as they match. And we only need bit 0. That can either be a 1 or a 0. And set value to 1 when pushed. So on release we repeat the same process. 66 Charlie 0. Bit 0 again, but this time we're going to set the value to 0 when released. Next up is the encoder. So we select the encoder from our list. On left, FSU IPC offset again. Enter the code that matches with ProSim. So for me, it's 66 Foxtrot 2. This time it'll be 2 bytes, and the value will be -1. So it'll decrease every time we turn it to the left. It'll be the same value as before. On the right, 66 Foxtrot 2. 2 bytes. And set value +1. Click OK. And the same again, but this time for the right hand encoder. As you can see, I'm using the hex code 66 Foxtrot 0, 2 bytes again, and the values of -1 and +1 in the set value boxes. Activate all the lines, and on the output side, and run. You can see the displays work nicely with ProSim and MobiFlight. The right hand one does the rear digits, and then the left does the forward digits, and the transfer button works without fault. That's it for this episode. There's the radio panel all finished. I just need to wrap it up and send it back to Mick in the UK. Hopefully in the next video I'll do something with my sim and I can finally get on and do some work here. Until then, I'll catch you later. Bye bye.